In this video, we are going to talk about animal-inspired robots, a decorative robot fish that can swim in all directions, an app-controlled drone that flies like a bird, the Robugtix T8X with 26 legs for multi-legged walking, the scorpion Hexapod that has a stinger that works like that of a real scorpion, a salamander-like robot that is useful in search and rescue mission, Eelume, which conducts underwater vehicle repairs and maintenance, an artificial jellyfish that has an electric drive unit and controls its own energy supply, a pneumatically driven fish that moves noiselessly in water, an ultralight flying robot that can fly in all directions, Spot Mini robot that can lift glasses, open doors, and operate both indoor and outdoor, an Octobot, which paves the way for a generation of soft robots. Number 11. MIRO. MIRO is an acronym for Marine Intelligence Robot, is a biomimetic decorative fish produced by the Korean company Airacuda. The fish is equipped with 4 laser sensors and an automatic swimming algorithm that makes it swim just like real fish. The robot fish can swim in all directions with more than 50 different types of swimming patterns. The lasers help it to detect and avoid obstacles and can also dive to depths of up to 50 meters. It is equipped with a camera and can be operated by remote control. With a fully charged battery, the robot fish could swim for 12 hours non-stop. MIRO is becoming a tourist attraction because of her colorful scales and occasional public stunts like swimming with sharks. Number 10. Bionic Bird. The Bionic Bird is an app-controlled drone that flies like a bird. It is an Indiegogo-funded project which simulates natural flight within 100 meters. The illusion is that it cannot be distinguished from other birds, and some birds even chase this remote-controlled robot to prey on it. However, the robot's functionality allows it to dodge these predators. Finally, let's note that this robot flies in a cathedral silence at 12 miles per hour on independent wings that beat 18 times per second, which is a faster wing speed than the majority of the bird species we have. The best part of this robot is the portable egg shaper charger that powers its ultralight battery. Number 9. Robugtix T8X. This tarantula robot is the ultimate robot toy. Not only does it look like a spider, but it also moves like one. It is a rechargeable, programmable, and wireless robot with 26 leg motors coordinated by an inverse kinematics algorithm. You can control the robot on your smartphone, tablet, or computer, instructing it to walk forward or backward, and its engine will automatically take care of all the complex mathematical computations, including inverse kinematics calculations, leg trajectory planning, leg gait coordination, and motor control. The T8X may not be able to climb walls like a real spider, but it can certainly cut a rug. It comes in plastic and hairy skin versions and can be yours for a mere $950. Number 8. Scorpion Hexapod. The Scorpion Hexapod was developed by 3 students from Ghent University in Belgium. It is a 6-legged floor crawler with 3D print body parts affixed to a plastic plate main body. The robot navigates around obstacles and moves multi-directionally using infrared sensor technology. It has a stinger that works like that of a real scorpion, and the red pen-tip stinger completes the effect. It fires its stinger at the hand of anyone covering its eyes, leaving a red mark as a reminder of the encounter. It is programmed with numerous moves and some auto responses to interactions. Its long-range IR sensor and 3 short-range sensors in its upper shell are used to detect user proximity. Number 7. Pleurobot. The Pleurobot is a salamander-like robot. Swiss Federal Institute of Technology spent years trying to make sure that the way Pleurobot moves is as close as possible to the way a real salamander moves. They combined high speed, optimization, cineradiography, dynamic scaling, 3-dimensional printing, and high-end servo motors to allow their robot to accurately capture the degrees of freedom, range of motion, and gait behaviors of the real animal. It has a salamander's articulated vertebrae, which allows it easily to traverse tough terrain. It also has a waterproof exterior and body parts. All this combined with a sophisticated neural network means this slithering amphibian is a great candidate for supporting search and rescue missions. Pleurobot has its own Twitter account. Number 6. Eelume. Eelume is an autonomous underwater vehicle created in Norway. It is an effective solution for conducting underwater repairs and maintenance. Its slender body and self-propelled arms allow for precise hovering and maneuvering even in strong ocean currents. One end of the arm can grab hold to fix vehicles, while the other hand carries out inspection and intervention tasks. One end can also provide a perspective camera view of a tool operation carried out by the other end. It can transit over long distances and carry out light inspection, repair jobs, and maintenance in confined spaces that are not accessible by conventional underwater vehicles. The vehicle's name was chosen because of its eel-like, elongated, and slender body. Number 5. Aquajelly. This is an artificial autonomous jellyfish with movements that are just as mesmerizing as the real deal. It is an indoor flying robot with peristaltic propulsion. It has 8 tentacles which it uses for propulsion, an electric drive unit, and an intelligent adaptive mechanical system. They either move alone or in a swarm and communicate with other robots to avoid underwater collisions. It also has a translucent hemisphere and a central watertight body that makes it as light as possible. Its movement is controlled by shifting its weight. 2 servo motors are integrated into the central pressure vessel to actuate a swash plate. This swash plate controls a 4-arm pendulum, which controls the direction of its movement. Aquajelly is capable of independently controlling its own energy supply by communicating with a charging station. Make sure to subscribe to this channel and give this video a like if you are loving the content. Number 4. Airacuda. This is a pneumatically driven fish. It is propelled by a mechanical fin drive. It has 2 fluidic muscles that control its tail fin movement. It moves smoothly and noiselessly through water. Airacuda has a waterproof head that houses all its electronic and pneumatic components. The hull can be flooded with either water or air, depending on whether there is a need to sink or rise to the surface of the water. The fluidic muscles are similar to those of real muscles. They are made out of a flexible hose made from rubber and embedded aramid fibers, which enable streamlined movement through the water. Number 3. Bionicopter. This is an ultralight flying robot inspired by the dragonfly. It can fly in all directions and execute the most complicated flight maneuvers. It can move each of its wings independently, and this enables it to slow down and turn abruptly, and also to accelerate swiftly and even fly backward. Bionicopter is a great deal larger than the insects which inspired it. Its wings are made of foil and carbon fiber and are moved by individual tiny servo motors that allow for 90 degrees adjustment. Number 2. Spot Mini. Spot Mini is a 55-pound dog-like body with a long dinosaur-like neck and an optional snake-like arm. These features allow it to do things like opening the door, lifting a glass from the sink, and putting it in the dishwasher without breaking it. It can also go up and down stairs, and it operates both indoors and outdoors. The robot has a quick disconnect battery, stereo cameras in the front, side cameras, and also a rear camera. All these features allow the Spot Mini to run with the big dogs. And number 1. Octobot. This is the first autonomous soft robot. It has a silicone exterior embedded with 3D printing, modeling, and soft lithography. It is inspired by the octopus and has no rigid components. Its movement is pneumatic and is powered by gas derived from a chemical reaction of hydrogen peroxide and platinum. It paves way for a new generation of soft robots.